is Geometry Chapter 6.5 in our textbook, which is titled Conditions for Rhombuses, Rectangles, and Squares. But our textbook is focusing on a precondition that every one of our figures that we're working with starts out as a parallelogram. So we're looking at specific cases where parallelograms are rhombuses, rectangles, and squares. So let's move forward. Those are all the topics we're going to discuss. In Theorem 6-16 states that if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So we start out with figure A, B, C, D, and that figure is a parallelogram because you can see the opposite sides are marked that they're parallel. And then the diagonals, the line segment BD and segment AC, those two diagonals are perpendicular, then this has to be a rhombus. And I have the right notation here. Look, I got a parallelogram ABCD is parallelogram, and AC is perpendicular to BD, then ABCD is a rhombus. That's true. Let's move on. So Theorem 6-16. If you have a parallelogram and a diagonal that bisects an interior angle, then the parallelogram is a rhombus. So this is, I sharpened up the definition from our textbook. It's a little more wordy. So if you take a look at this, then angle ABC is marked congruent as angle DAC. Therefore, AC, that diagonal, is bisecting an interior angle of that parallelogram, so ABCD has to be a rhombus. Okay? And it could work, also if we marked that this angle was congruent to that angle, that would work as well. So our next theorem, Theorem 6-18. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So we start out with ABCD is a parallelogram. Look, I have that specified here. And then, and you can see in the picture, I got the same situation. The opposing sides are parallel. And then if AC, that line segment, that diagonal, is congruent to BD, then it's a rectangle. And it is. Now the image to the right, this is almost following what we're describing, except it's not a parallelogram in the first place. See, look, the diagonals are congruent, but it is not a parallelogram, so therefore that is not a rhombus. It's an isosceles trapezoid. We'll learn that later. About squares. So what we need to know is that in this lesson, if we have a parallelogram that exhibits the properties of both a rhombus and a rectangle, then it's a square. So let's start applying all these theorems one by one. So in this image here, we have a parallelogram, and we're going to apply Theorem 6-16, where if the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So look at the slope. You start here at B, and you're going down 2 spaces. Each space represents 2 units. So you got 2, 4, and over 2. BD has a slope of -2. And if you look at this blue diagonal here, you're going over 2 spaces, really 4 spaces, 4 units, but you're going over 1, 2, and up 1. This is a slope of +1/2. And we learned earlier this year that if you take the 2 slopes and multiply them against each other, the -2 times 1/2, and if you get -1 as an answer, then you can conclude that those 2 line segments are perpendicular to each other. So since the diagonals are perpendicular to each other in a parallelogram, then we can conclude that it's a rhombus. Next theorem. Oh, it's the same thing. It's just the same theorem. It's just that we're going to use Pythagorean theorem to do the job. So if you're given this parallelogram, and AE is 3, and BE is 4, and AB is 5, if you set that up, a squared plus b squared equals c squared. And if it works, then you know it's a right triangle. And it does work. Look, I got 3 squared plus 4 squared is equal to 5 squared. That's 9 plus 16 is 25. Clearly that triangle is a right triangle. If it's a right triangle, we're picking up a right angle right there. And if we're picking up a right angle, then that means the diagonals are perpendicular, and it started out as a parallelogram. Once again, we have a rhombus. Next page. So Theorem 6-17 says that if we have a parallelogram and the interior angle is bisected, then it's a rhombus. So we have a parallelogram. I have an expression for this angle, an expression for that angle, and you're being told that x is 13. So if you set those two expressions equal to each other, given that x is 13, substitute in the value of 13 for x, the two x's, and work out the arithmetic. And when you find out that it ends up as 58 is equal to 58, then you know that this angle here is congruent to that angle there, and since we started out with a parallelogram, then, and the diagonal bisected it, that interior angle, then you know it's got to be a rhombus. Yay! Next problem. Let's see, what are we doing? Oh, we're working to see if it's a rectangle. Okay, so if we have a parallelogram, and if the diagonals are congruent, then it's a rectangle. So we start out with CE is 5. BD, this entire length, is 10. Diagonals on any parallelogram bisect each other, so if this is 5, this is 5. And if this entire length here is 10, that means those two are also 5. So since this line segment is 10, that diagonal, and this line segment is 10, that other diagonal, they're congruent, then that parallelogram is a rectangle. Okay. And now let's see if this figure here, hike, is a square. Well, our first test is we're going to test slopes. So we're going down one space, 2 units to a space. So we're going down 2 and over 2, 4, 6, 8, 10. So this slope simplifies to -1/5. And this slope here is over 2 and up 2, 4, 6, 8, 10. So that simplifies to +5 over 1 and up 5 spaces. So we take the two slopes, multiply them against each other, and we get -1, which means that we can conclude that these two diagonals are perpendicular. So once we reach that, we now checked off that it's a rhombus. Next thing are the diagonals congruent? Well, we can use Pythagorean theorem, so 2 squared plus 5 squared, and take the square root of that. Is that equal to the square root of 2 squared plus 5 squared? Yes, it is. So therefore, HK is congruent to EI, so the diagonals are congruent, so we can conclude that it is also a rectangle. And if it's both a rhombus and a rectangle, then we conclude that hike is a square. And that's it, I think. Thank you for watching this lesson.